consider this problem statement. So it states that the product of all possible roots, that is for this given equation, it is k, where this t naught or this t subscript 0 is minimum of this particular set. That means we need to resolve this particular inequation and we need to figure out or compute the minimum value for t. So in that case, whatever is the value of k, we need to report the absolute value for this k. So we'll move step by step. So first of all, if you observe this quantity, we'll try to resolve all of this one step at a time, right? So you can observe here this particular mathematical figure. So this 27 can be written as 3 power 3 and this 8 can be written as 2 power 3, 2 to the power 3. Now we'll use a logarithmic identity which states that if I have something like this, let's say log of a, and here power is let's say p, and in the base we are having log of this b, and in this power we are having let's say q. So this can be written as p over q times log of argument a and then base as b. So this I can write simply as a. So I will be using this particular identity to resolve this particular sub expression, right? Now moving forward to the next step. So this one, on applying the property, so here this 3 to the power 3, this 3 will jump out here and this 2 will be written, this 2 power 3 will be written here, right? So this can be simply be written as log of argument 3 base 2, and this 3 over 3 cancels out to 1, and this parenthesis is not required, right? Now in the next step it is very clear that this 3 over 3 resolves to 1. Now I will be applying the property of exponent which says that if I am having 2 to the power m plus n, so this addition can be converted into product, right? So I will take this one and convert this to product. So this can be written as 2 to the power log of 3 base 2, and I will remove this one, and in this part I will write 2 square, right? Now there is one more logarithmic property which goes somewhat like this, that if you are having something like a to the power log base a and in argument you are having b, so this generates the answer only b, right? So I will be using this property to resolve this one. So on resolving this further, so this turns out to be 3, and on solving this further we get the answer as negative 2. So for this expression we got the answer is negative 2. Now we'll target this next one, that is t naught. So let us solve this part, right? Now this is something that is given to us as t subscript 0, and we need to resolve this, and whatever is the minimum value, that minimum value is the one which is the required value for this one, right? Now here we can say that so I'll just arrange it little. Here this inequation, I'll write this inequation and solve it further, right? So this inequation will convert this into, so if you observe here log base 10, log base 3 and log base 2, so positive bases are there, right? So this one will convert into exponential form, that is this particular term I'll write here, and this is greater than equal to 10 power 0. So this logarithmic structure I have converted to exponential form, and I'm going to repeat this again and again. And we know that 10 is non-zero, so whenever we have a non-zero number and the power is 0, so in that case the result is 1. So this result will be 1, and again I will convert this into exponential form. That means this time this will be log 2, and here log of t base 2, this will be greater than equal to 3 power 1, that is indeed 3. And from this if I solve it further, so it is very clearly visible that t will be greater than or equal to 2 to the power 3, which is 8, right? So from this one we can say that this value will be equal to 8. So we have resolved this part also. Now we will be solving the equation, right? So now we are ready to attack this particular equation that is given to us, right? So I'll write this one as it is first of all, and maybe I'll just reduce the font size little. Right. Now proceeding to the next step. So first of all, whatever resolved quantities are there, I'll replace those first of all, like this t subscript 0. So I'll replace 8 here, and this particular value which we have generated here, computed here as -2. So this -2 I'll be substituting over here. Now I'll be applying the property of logarithms further on this. So if you observe this 8, so this 8 can be written as 2 to the power 3. If you observe this 1 by 4, this 1 by 4, 1 over 4 can be written as 2 square, and again in turn this can be written as 2 to the power -2, and this entire sub expression is the base of this logarithm, right? So now after this refactoring, I will again just apply the property of logarithms here. So if you observe here, this is power 1, right? This is the implicit power 1. So this can be written as 1/3. So this exponent 1 comes here from the argument, and this 2 power 3 which is in the base of log, these 3 comes here, right? And this is the property which we observed right now, that is this one, right? Similarly I'll be applying the property here as well, right? So this -1 I'll bring it over here, and this -2 I'll remove it from here and I'll put it over here, right? So this is simply log base 2. Now, so after applying this property, you can observe, so one thing that I should remove here is this 3 must be removed from here, right? So this is simply 2, right? And now this power 1 is not required anymore, and this will become 1 over 2, right? Now what I will do, for simplicity I'll use the concept of abstraction here. So this particular quantity I will assume it as some variable. So let this quantity be u, right? And now I'll be proceeding with this further, right? So let me just adjust the font size. So this has to be right. Now here wherever I'm having this log base 2, so this one I'll replace it by u, and one time u will be u as it is. Similarly, this one also if I replace it by u, so one times u will be as u itself as it is, right? Now this is the simplified expression that we are having. Now we'll be using the property, another property of logarithm, which goes somewhat like this, right? So it says that if I have, let's say, log of a and base b, so I can take intermediate base and split this into numerator and denominator. So it says that I can take log of some base of my choice as a, the argument goes in the numerator and the base goes to the denominator. So here I will take log base 2 because here -2 is there, again here we have 2, here we have 2. So with a hope that this will give larger amount of simplification, so in that case we will be using this particular identity, right? So now we will proceed to the next step. So I will be using this particular property. So from this one, I'll convert it in this way, that is log of log base 2, I'll consider log base 2, and here in the argument I'll be writing this u by 3, right? And then again we'll write log base 2, and the argument I'll write 3/4, I'll write 3/4. Similarly, the same thing I'm going to apply here, that is whatever is the argument, that is u over 2, this one I'll write it as it is, and whatever is the base, that is half, I'll write it as it is here. Now I've taken log base 2 as the intermediate base. Now if you observe this, so from this one I'll convert this division into subtraction, right? So this one can be written equal to log base 2 of argument u, and here log base 2, and here it will be 3. The same thing I can do it for the denominator as well, right? So this one will be log base 3, and here this will be log base 4. I'm doing it for this denominator. Similarly I can do the same thing here as well, that is log of argument u base 2, and here it will be 2 here, right? And the same thing here as well, that is in this case as well, if you observe this one I can write it as log of, So this one will be log of base to 1, that will be 0 obviously, and this will be log of 2 and base 2, this would be 1, right. So this on further, on resolving all these terms further here, right. So I'll just resolve this further. Now this is 0 minus 1, this is 0 minus 1, and that is negative 1, right. And this log of 4 base 2 would be 2 here, and this would be 1. Now after resolving each of this, I'll be performing algebraic manipulation over here, right. So in the next step, so this one I'll eliminate. My this denominator would be negative of log 3 base 2, and this and this negative one, if I multiply with this will become positive 2. So this in turn becomes this, that is minus log of 3 base 2 plus 2. Now I'll be resolving this further. So this will be negative of log u base 2 plus this would be log 3 base 2. Next, this will be again log 3 base 2 times log 2 base u, and then again minus log 3 base 2 minus 2 times log 2 base u and plus 2 at last. So this is the expression we are having. Now if you observe here, this positive log 3 base 2 can be cancelled with this negative. So that is the cancellation that we can have. Now on proceeding to the further step, we can write this one as, so this one can be written as log of base 2 u. This one I'll consider as the common factor, and instead of this one I'll write negative 1. Then with log 3 base 2 we were having this term, so this log 3 base 2 will be written as it is, and with this, because this one is taken at the this as the common factor, so here this would be minus 2, and I'll write plus 2, that is equal to minus 2 times this particular quantity, minus 2 times this particular quantity. Now I will be proceeding to the next step. So from this one we can observe that this 2 we can add, we can subtract 2 on both the sides. So here this will be minus 2, and on resolving this further, we can write this one as, so I'll just write this expression in the next step, right. So I'll go to the next step and write it. So this one can be written as 2 times log 2 base 3, and this would be 6, right. So this would be minus 6 over here. Now if you observe this one, that is minus 1 and then negative 2 here, so this becomes minus 3, right. On resolving this becomes minus 3, and if you observe, if I take 2 as the common factor, then this can be written as 3. Now if you observe the interesting fact over here, this is a positive quantity, and this one is also a positive quantity, right. Is it positive? No, right. But the thing is that these quantities are same, positive or negative, that is secondary, but these two quantity, if you see, these are same, so we can cancel them. The thing is that these are non-zero, and non-zero terms can be cancelled. Positive or negative, that is another thing, but here these are non-zero terms, so this can be cancelled out, okay, and they are same. These both of the quantities are same, and hence this can be cancelled out by one time. So finally we can write this one as log of u base 2, that is equal to 2, and from this we can say that the value of u is equal to 4, that is 2 square, that is equal to 4, right. Now we are having the value of u. So now I'll take this assumption based statement here, whatever I have assumed as u, so I need to resolve this further, right. So this is the given equation. Now the value of u is something that we already know, so instead of this I am going to replace it by 4. Now I will convert this logarithmic equation into exponential form, that is x square plus 7, that is equal to 2 power 4, right. So 2 to the power 4, that is nothing but 16, right. So in the next step I can write this will be 16, and on subtracting 7 on both the sides, I will subtract 7 on both the sides, right. So this will yield further So this will yield, this one will be 0, and here 16 minus 7 will be 9, and from this we can say that x belongs to the solution set negative 3 and positive 3. So these are the two acceptable answers for x. Now the thing is that we have to get the product of this, whatever possible roots are there. So you can observe that x can have the, we can accept the value of x as negative 3 and positive 3 both, because x square plus 7 is something which is always positive. In x, whether you substitute positive value or negative value, this quantity remains defined. So therefore we can consider both of the roots. So from this we can say that the product of all possible roots would be, so this k represents the product actually, right? So this is minus 3 times 3, that is nothing but negative 9. But we need to compute this absolute value of k. So absolute value of this negative 9 would be 9, and hence 9 is the answer to this particular problem statement. So that's it. So we have used multiple properties of logarithms, exponent, equations, right? And hence we got the value of k, that is 9 as the answer.